Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level puzzle, but it's not a Sudoku puzzle, it's a Minesweeper puzzle. And so this is another type of puzzle. This one is called Japanese Minesweeper Beginner, and it's by RD. And here are the rules. We have Minesweeper, where there are 10 mines in the grid. Every clued cell that is a non-mine cell that is orthogonally or diagonally adjacent to at least one mine contains a digit equal to the number of adjacent mines. And cells not adjacent to any mine are left empty. So this is traditional Minesweeper, where basically the if the cell is adjacent to orthogonally or diagonally, and orthogonally just means sharing an edge, but basically horizontally or vertically connected to a mine, any cell that is orthogonally connected to that is neighboring a mine or is adjacent to a mine, whether orthogonally or diagonally, um, has a digit which is equal to the number of adjacent mines. So say we had mine here, and mine here. Then this digit here would have, and those are the only mines in this 3x3 area, then this would have to be 3, because that would signify how many mines are touching that cell. And this is classic Minesweeper for anyone who's ever done the Minesweeper game or played the Minesweeper game on, like, I think it was the one that I played originally was on Windows, but there are many of them now available in other platforms and stuff. Anyways, so that is Minesweeper. We also have Japanese sums, where clues outside the grid represent the sum of digits in each contiguous sequence of clued cells in the order of appearance from left to right or top to bottom. And consecutive sequences must be separated by at least one mine cell or one empty cell. A question mark represents any digit from 0 through 9, but for a double-digit number, its first digit cannot be 0. Wouldn't it also, like, it doesn't make any, so I think I've ran into this problem before with Japanese sums, but anytime there's a question mark, a single question mark, that also cannot be 0. Because if you have 0, that doesn't really make any sense when you're separating out a sequence, right, for the digits in this row, right? So the singletons question marks also cannot be 0, but also for two-digit numbers, the first digit cannot be 0, but the second digit could. So keep that in mind. So for example, this must be some sort of sequence where you have numbers adding up to a sum here, which is a single digit. Then you could have any number of mines and empty cells here, and then you have another sum going this way. And then you could have empty cells here or mines here. We don't know. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, anytime you have a mine in a column or a row, you are guaranteed that that it has to have a number before it and a number after it. Right? Because unless it's all full mines, but you can't, right? You can't have all these be like so say this is the interesting one. Is this 4 that's by itself? I think that means there are no mines in this column, right? Because if there's mines in this column, the problem is you would have to have a number in front of it and then a number behind it. I guess you could have a mine here. You could have a mine here and then you have digits here, summing up to 4, and then no mine afterwards. Or you could have a number here with the mine there. Okay, so mines it cannot be anywhere in these cells here. Because if there was a mine there, you would have to have a digit in front and a digit behind. Well, okay, that's not necessarily true. You could have 2 mines here, right? And then that would be the case. That is interesting. Okay, so that's not necessarily the case. Um. So you technically could have like 4. You could have actually 8 mines here. Ugh. We have a leaf blower right outside. Anyways, so technically you could have 7 mines here. Is that actually possible though? Ugh, this is really annoying. Um, oh, actually, I don't even know if you guys hear the leaf blower because it's coming every now and then, but I guess you can't. It's being filtered out by my mic, which is good, I guess. Actually, it's not the mic. I think OBS is actually is because it's noise. Um, yeah, it's occasionally coming through. Anyways, what do we have here? So we have to have to add up to 4. You could have a 4 by itself, but that's kind of problematic. I guess you could have something like 3 and 1 there as mines. That's possible. So you could have just a 4 by itself, which means there are 4 mines surrounding whichever digit is here. Or you could have 3 and 1. You could have 1, 1, 1, 1. No, you can't have 4 by itself. If you try to have 4, how is that going to work, right? You're going to have 2 digits here, two mines here, 2 mines here. And then how does that work? You would have to have 4 in each of these cells. So that's not going to work. If we have 1 here, that means there's a guaranteed 1, 1, 1 there. So we have 1, if we have 1 on the side, that's guaranteed to be 1, 1, 1. Can we have 2 on the side? Then that would be, how would that scenario work? 1, 2, 2, 1. Which is already too large for 4. So I think the scenario has to be 1 on the side. Well, not necessarily. I don't think you can ever have it on both sides, right? If you have 2 on both sides, then all of these must be 2, which is going to be too large for the sum. So you're going to have 1 at the end. And if you have 1 at the end, this is obviously going to be at least 1. Unless there's multiple, right? But this doesn't change the scenario here. So we could have 1 here and then a red here, which would be 1s all there. That is possible. Or 1 being there, right? Basically it counts for 2 sets. Can you have red and red there? The problem is these then have to have if you try to have red, red, red this way, this before, the problem is this also has to be a 1. So that's not going to work. And if you just have 2 reds here, basically anything on the side is going to guaranteed to have a 3. Right? 3 1s here. So any mine in either of these columns will guaranteed give you 3 this way. And the unless it's here, right? In which case that gives you 1. But we can only have at most 3 cells here to give us 3 there. And then how do we get 1 this way? We can't, right? Because the problem is this would be 1, and then there would be emptiness in between, which is not allowed. Because it has to be 4 all in a contiguous sequence of clued cells. And otherwise, if we have something like red, red here, this is guaranteed to be 2, and that's guaranteed to be 1. I guess you could do then something like this. Or something like this, right? Then that would be 3 and 1. So that is potentially possible. Interesting. Okay. So what are the possibilities? We're guaranteed at the end one of these is going to be at least, actually at most, one of these has to have a mine in it. Then we could do something like this, which works. That's then 3, and then that would be 1. That would be 1. That actually works there. For the 4 there. And then something like that, and then the rest are not. Or you could have something like this is a singleton 1. You have a mine here. Actually, I think you could even have a mine here, right? And then this is 2, 1, 1. But the thing is, okay, so you could have multiple ones here, right? The problem with this, though, I guess it could be something like 4 here, and then this is 4. That is possible. Then this would be 2 here. That would be 1. You could have something like a red here. The problem is this is too many mines probably being used here. I guess part of the problem also is we have to figure out how... So this is guaranteed to be 2 mines here. 1 at least. 1 here, and then a 1 to add here because we can't have, well, I mean, we could technically have 4, but it has to be at least 2. It can't be less than, it can't just be 1 mine, which gives us the 4 here. So that's interesting. We do have 2 double digits here. So every mine can account for 3 in a column or row at most for the Japanese sums, right? So that means since this is a set of, because a mine here can give you 1 each in those cells. Same with a mine in any of these columns. A mine here necessarily is going to be less. Right? A mine here can only account for 1. A mine on the line, but not on the edge, would account for potentially 2. It could still account for 1, if depending on how many mines are here. So that means this is at least 20 here in this column. That's guaranteeing 7 mines, I think. Right? Because we can only account for at most each mine on the side accounts for a set of 3. Or giving us 3 in value in that column. At most. So then that's guaranteed to be 7 around here. This accounts for 2. That means this has to be 1, right? I think that's the case. Because 1 on the side could give you 3. That's interesting. Then we have 1 here. So if these question marks account for 7 of them, this counts for 2 because you can't have only 1 can only give you at most 3 in value in the column. So that's 7 along these 3 columns. That means there's 2 along these columns at minimum. And this then has to be 1. And it has to be 1 divided by another. It has to be 1 and 1 on each side. Which means none of these are going to be none of these are going to be mines. None of these are going to be mines. The question, though, is we don't know if there's emptiness, right? This can't be a mine, and this can't be a mine. But we could have a mine anywhere else here. We're going to have 7 in these columns. So it's at least 6 digits each on the sides, because that gives us 18. And then it could be another 1 on the side or 1 in the middle. We don't know. And that accounts for 7. So then we have to have 2 here. So it could be on either side that's the case. Hmm. Hmm. So it can't have more. So it has to be a combination of this is a mine, and then one of these are mines, right? You could have mine here, then that would be 2, 1, 1. Mine here. So the mines cannot be in the middle here. So we have to have a mine on the outside in one of these two. So what happens if we have a mine here? Then one of these has to be a mine. Okay, so I don't think this can't be a mine. If we have mine here, this would be 2, and this would be 1, and it doesn't add up to 4. So these can't be mines here. No mines here either. So if we have mine here and mine here, what would this look like then? This would be 2. We'd have 2, 1, 1. This would be 1, and this would be 2, at least, which is too big. So that doesn't work there. What happens if we have mine in one of these spots? That means this is 1, 1, 1, 1. Oh, we have a similar issue here. And then this would be 1, 1, 1. But we could have a 1 here, right? That's interesting. So one thing we do know is it cannot be here, because then this would be 1, 2, 2, and that would be too big. So this is not possible to be a mine there. We cannot have a mine here, right? If we have a mine here and a mine here. If we have a mine here, that's 1, 1, 1 there. But there's no way to get another mine in any of these columns. So we can't have mine here and mine here. We could have mine here, 1, 1, 1. So how does that work? I guess you could have mine here and mine here. That would force this to be 1, 1, 2 there. Can we have this as empty is another question, though. If we have that as empty, that means these are flat. This has to be 1 here, and we could have 1. That would mean none of these could have mines in them. So these would all be 0. This could be a value. It cannot be 4 by itself. This cannot... Okay. I guess that could work, right? You could have a mine here. This would be 1. That would be 1. You'd have 1 and 1 there. That's fine. And then you'd have to have... You cannot have 4 here. But it can't be 3 and 1. How does that work? So then... Okay, you can't have a mine here, right? This would then be at most 3 for this segment. Yeah. But you could have something like this, which will give you 1, 1, 1. And then you could have something like that. So then this would be, how would that be? 1, 1, 2. This would obviously be 2. Obviously, this would be 1 here. 1, 1, 2. You cannot have something off this, so then this would have to be red. So this would at least, so we'd have guaranteed this is 1. Obviously, none of these are mines. We don't know what these are, but this has to be 1. These are then empty. That's interesting. So we have 1 here, and then we don't, this is also 1. This is problematic, though. Because, I guess not. You could have something like this, and then that. So that's how that would have to work. Same with this, right? We have to have a number. The problem with this, though, is it can't be 4. That's going to be kind of problematic. Right, you're going to have something like this, which would give you 1, 1, and then something like that. But the problem with that then is that this is going to be at one contiguous block, right? This is 4. So we cannot have, I think we've proven then that this cannot be where this is at. It cannot be mine here, because then this gets into a weird situation to get this to be 4, and then that's a weird situation to get this to be 4. So I think then that guarantees this has to be the mine. We could have mine. No, we can't have mine here. That would be 2, 2, 1. So this is not mine. So we are guaranteed this is 1, this is 1, and this could be 2, or it could be 1 and then another 1 here. We're not sure. So that means we cannot have mines be here. We can't actually have mines be here either. Again, you can't have mine here, because then that would give too large of a... that would be too large here, right? You'd have 1, 2, 2 at minimum, adding up to 5. So that means one of these 2 is a mine. So we're guaranteed then this has to be 1, 1, and 1 there. This has nothing. So these are empty. One of these is going to be a 1. One of these is going to be a 1. But this is empty, because there are no mines surrounding it. This is 1. This is 1 or 2. This is 1 or 2. It cannot be 1 here. If this is 1 here, so I think we always have to have a mine here, right? If this is 1, you can't have another just 1 by itself. Well, you could. No. Well, maybe. No. So say well, if you have 1 here, you could have a red there, and then that's 1. That is possible. So one of these two was a mine here, right? Either we have a mine here, this becomes 2, or we have a mine here. So one thing we know is these can't be mines, because if these were mines, then with that and that, this would be 2, and then we'd have 1 here if this is not a mine. If these two are mines, the problem is this would then be 3. So this cannot be mine, and this cannot be mine. Okay. This can't be a mine. If this is mine, this would then be 1. Well, okay. If this is mine and we tried to have a mine here, so if we had mine here, this cannot be a 2-digit sum. So obviously that doesn't work. And if we try to have both of these be mines, then this would see 2 mines and would be 2. So then we have 2, 1, 1, 1, which adds up to 5. So this cannot be the mine. This has to be a mine, which makes that 2. This is 2. We could have mines here. We can only have at most 1 mine. Actually, that's not even going to work. We cannot have a mine just on the ends. If we have a mine on the end, that only accounts for 1 in the column, right? So this cannot be a mine. This can't be a mine for the same reasoning, because then we would have 19 in this column, only accounted for by the 7 mines in these 3 cells. So since this is guaranteed to be a number, yeah, maybe I should make greens be guaranteed numbers. So these are guaranteed numbers. These are guaranteed numbers. These are not. Gray are non-numbers. This is a guaranteed number. It's going to be at most 1, potentially 2, 3. So we need that as a number. That's potentially 1, 2, 3, 4. So then this has to be a number. We have nothing here. If we cannot have a mine here. If we have a mine here, this would not be size 4. We could have a mine here, and that would give us 1, 1, 1. Or 1, 1, 2, with this being a mine. That is potentially possible. Can we have something where we have 4 here? So say this was not a mine. If we did not have a mine here, these would then be empty, obviously. These... So you'd have to have 4 blank 4 blank 4. Or 4 blank something blank something. So 4 mine something mine something. But this is never going to have a 4. So that does not work. So therefore, this must be a mine here, which means none of these can be mines. These then have to be values. These cannot be. So that's empty. This is empty. We can't have something on the side here. We cannot have a mine here because then this would be an extra portion that doesn't add up to a 2-digit sum. So we can't stop here, which means I think we have to have a mine here, which means all of these are green. This is going to have to sum up to some sort of 10 thing. So here we have 1, 1, 2 to add up to 4. These are empties, so this must be non-number. And this has to be a number. So this is guaranteed to be a number, which means one of these has to have a mine. So I think it has to be there. It has to be there then. Therefore, these are all numbers. Okay. So then we have guaranteed 1, 1, 1. We don't know what that is. This is 1, 1, 2, 1, 1. That's going to be 1. This is 2. This is at least 2. We have similar situation here, right? This has to be a green, has to be a number, and then this has to be a mine or a blank spot. But for this to be a number, it has to have a mine in one of these 3 cells. If this is mine, then we don't have blank spot here unless this is a mine. So this is guaranteed. Oh, We don't know this is green, right? These do have to be green. They can't be another mine because then this would add up to too big of a number. We do have to have this be green because that's green. One of these 3 is going to be red. And we need either a gray cell or a red cell here. And it cannot be gray because one of these is going to be red, which means this has to have to be a number if it's not a mine. Therefore, we know this is number here. But we don't know. You could have a mine here. That is... Oh, no, you can't have a mine at the... Again, at the ends of this grid because the problem is then that accounts for 19 digits in column 5 because this only can give you... This mine can only give you 1 here. So we could have a mine there. This then has to be guaranteed. So we have guaranteed 1, 1, 1. We don't know if that's guaranteed. This is guaranteed 1. Guaranteed 1. This could be open to this. These can't be mines. So that has to be a number and a number there. So we don't know what these are. So this has to be 2 or 3. Technically, it could be 2 through 5, but this is not going to be a sum of a 2-digit sum. So we have to have green there. So that does leave that situation there anyways. This is either going to be 2, 3, or 4. Okay, so this has to be green because of the same scenario here, which means one of these is red. So if red were here, that means we are guaranteed this cannot, one of these is going to be red, which means this cannot be gray. So therefore we need a red there. That leaves these as numbers. This is guaranteed to be 1. This is 2 or 3, same thing. This could be 2, 3, or 4. This we don't know. Okay, what happens if we have one here? That could potentially work. This we don't know. Let's do maximum. Let's do possible ones though. We could have one. Technically, we could have 1, 2, 3, 4, 5, 6. So this could be up to 6. It's very unlikely to be 6 though. If it's 6. This is 1, 2, 3, 4, 5, 6 mines. We have a 7th here. So 1, 2, 3, 4, 5, 6, 7. We only have 3 more here available. So this can't even be 6. So same thing with this, right? This could technically be up to 6, but we already have 6 mines available. We have a 7th here, and then 3 more possible here. So this is 2 through 5 here. This sees 1 and up to 3. So 1 through 3. This sees 2 and another 1 possible. This sees 1 up to 3 there. Can we ever have an empty spot there is kind of the question, right? So if we have empty spot there, that means none of these can be mines. That means this is gray. This is gray. And this is not going to have 3 unique digits here. So the answer is no. This cannot be an empty spot here at all. Can this be empty spot? On either side. Let's try. If this is empty spot, that means these are not mines. So this would be green. These would have to be gray. You'd have gray there. We don't know, actually. This could be blue. And this would have to be red. But then this would be 3, 3, and 3 at most. So the answer is no, this cannot be empty spot. And this can't be empty spot. So one of these is going to have to be a mine. Interesting. Well, we know this can't be empty spot. Can we have empty spot here, or mine here? Um, This is 1 or 2. This is 1, 2, or 3. This is 1, 2, or 3. This is 1 or 2, 1, 2, or 3, 1, 2, or 3. We don't know which ones of these are. So this is going to be 1. It could be 2 or 3. This could be 1 through 4, technically. Okay. Yeah, here you're hearing the leaf blower. So, so how does this... So this can never be an empty cell. So it's either a number or it's a mine. Can this be just a number then? If this is number, one of these has to be a mine at least. So mines could definitely... Mine has to appear somewhere here. That means this is 20 for column 5 as the numbers. Because the mine here only gives us 2 in this column. So there must be 6 mines in the columns 4 and 6, and then 1 in column 5 somewhere. Can we ever have gray cells here? Okay, so if this is gray, that's not going to work. Because then all of these become non-mines. And this would then be gray. And we would not have 3 consecutive sums here. It would have to be 1 and 1 at most. So this cannot be gray. Can it be mine? Maybe. If this is mine... Can we have mine? I don't think so. So we can't have an empty spot here. What about an empty spot here? That would mean there's no mines here. Therefore, you would have to have a mine there. This would then be green. We'd have green here. That is possible. These would be gray. You have gray there. And you could have... This would then have to be green here and green here. And then this would be mine. Okay. So that is possible there. Interesting. We know then one of these has to be a mine. Oh, these can't be mines. Oh, that fails then. This is just be one contiguous section. So no, that cannot be. We cannot have an empty spot here. Can we have a mine here is the question. If we have a mine here, we have, this is 1 at most, and so we cannot have a mine here. Therefore, we need to have mine here and mine here because these can't be empty. That leaves these as green. This as green. We have 6, so that means we have all the mines in columns 4 and 6. So this must be green here. These must be green. These must be green. This must be green here. And same with this. So we have to have one of these. So this has to be non-mine. So there must be green here. So one of these two is a mine. Okay, so then we know exactly how much these... Well, okay, so this then has to be... we know this is 2, this is 2. This is 2 or 3. If we have a mine here, this is not going to add up to the correct value. 2 here, 2 here. But we have the same problem here. So that's not going to work. I think that's... Okay, we know this is 1. We have 1, 1. This could be 1 or 2. This is 1, 1, 1, 1, 2. This is 1 or 2. This we have 1, 1, 1, 1, 1. This is 1 or 2. That's problematic. Oof. 1 or 2. 1, 2 or 3. 2 or... Yeah, because then this becomes 3, 2, 2, and then we have 3, 2, 2. But that's not large enough to add up to 10. Shoot. This can't be a mine. That's the problem. Shoot. How does this work then? Yeah, neither of these can be empty because then that forces all of these to be non-mines. So let's just double check that again. These then all become non-mines. That gives... The problem is that makes this empty. And then we don't have 3 separate contiguous sets there. So that's why that can't be empty. Same with this. If this is empty, this is all blue. That would leave that as red. These would all be empty. And then these would all be green. Yeah. That's the problem with that one, that being empty. So the problem with this being a mine is we have stuff beforehand, but we can't break this apart. Because this can't be a mine. Oh, actually, that could work. So we showed this doesn't work as mine. But what happens if this is mine? Then this would have to be something. Can't be mine because we have two mines here. Then this would not be contiguous set. Blank, a mine or blank, then contiguous set. But this could be blank. In which case, these are not mines. And that could work. So then this has to be blank. These have to be green. They're next to a mine. And this could be something. So then we have blank here, which means this has to be red. So these are then green. And that could work. Okay, so then this has to work this way. We could have a mine here, we don't know. So this has to be then green here and green here. That's not, yes, because you can't have another mine here because then this doesn't add up to 20. So then this becomes 1. This is 1. This is 1. We have 1 here. This is 1 here. 1 here. So then, yeah, that's how that works. This must be at least 1. It could be a mine here, technically. No, we can't have a mine. So the mines cannot... The mine cannot be here because that would affect only 2 cells. Same with this. So then this is green and this is green. So we have 2 more mines here, which must affect 3 cells. We can't have mines in any of these spots because they would only affect 2 cells here, which means this must be mine here and this must be mine here, which means this is a green, this is empty, this is a green, and we are done. So now we can count up how many of these digits. So this is 2, 1, 1, 1. No, this is 2. This is 2, 2, 1, 2, 1, 1, 2, 1, 1, 2, 3, 3, 2. And this is also 2, 3, 3, 2. This is 2. This is 1, 2, 2, 1. And this is 1. And that should be the solution. Do we just remove the coloring? How do we actually get this to solve? Let me take a look. It doesn't say anything for how to actually solve it. Okay, let's just double check though. This is question mark 2, 3, and 4. So that satisfies that. This is 4 that way. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 mines. 2, 3, and 4 satisfies question mark 4. 1, 1, and 2 satisfies question mark 1. That's 4, 3, and 2 satisfies 4 question mark. 2, 3, 2, 2, 2, 3, 3, 2 is 10, 2, 3, 3, 2 is 10, and this is 4. So that satisfies those. 1 and 1 satisfies that. So again, these are all surrounding 1. These touch 2. This surrounds 1. We have 3, 3 here. This is 2 surrounding that. 2 surrounding that. 2 is there. 1, 1, 2, 2, 1. 2, 1, 1, 2, 2, 1, 2, 2, 1, 1, 2, 3, 3, 2. These are all 1, 1, 1, 2, 2. These are all 1 surrounding this, 1 surrounding that. I don't even know. Yeah, I don't know how the... maybe just remove the coloring. That's... Oops. Yeah, I don't know how... I'm pretty sure this solved everything, so that's fine. But, yeah. I don't know how to finish it, right? It doesn't say how to solve it. I'm pretty sure this is the solution, though. So... Anyways, that's the solve. It's interesting, though. It's sort of a reverse Minesweeper. Well, is it? Yeah, it's kind of a reverse Minesweeper, right? Where you're not just randomly clicking on spaces, but you're trying to fill in the spaces. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.